Our lesson today is to be able to classify quadrilaterals and also to be able to find the missing angle of a quadrilateral if we're given the measure of the other three. All right. A quadrilateral is a polygon with four sides. The diagram shows the properties of different types of quadrilaterals and how they are related. When identifying a quadrilateral, use the name that is most specific. Okay, a quadrilateral is a four-sided polygon. We have 1, 2, 3, 4, four sides, and it is a closed figure made up of segments. Definition of a polygon. If we have a then we have a trapezoid, which is also a quadrilateral, right? That's the connection here. But a trapezoid is a specific type of a quadrilateral. It is a quadrilateral with exactly one pair of parallel sides, right? And if you look here, right, we see the one pair of sides that are parallel. The red arrows indicate parallel sides. So I see one set of red arrows here. It's only one set of parallel sides. Next we have a parallelogram. Parallelogram is also a quadrilateral because it's a four-sided polygon made up of segments. But it is a quadrilateral with opposite sides that are parallel and congruent, right? If we look and see the red arrows here, we have opposite sides of parallel here, opposite sides of parallel here, but we also see congruency marks, where I see this side is congruent to this side, those opposite sides are congruent, two congruency marks here, two congruency marks here, those sides are congruent. So both pairs of opposite sides are parallel and congruent. Next we have something called a kite. A kite is also a quadrilateral, but it's a quadrilateral with two pairs of congruent adjacent sides. Well, what does that mean? Well, adjacent means next to. So here's a congruent, these two sides are congruent. They are adjacent to each other, right, because they are next to each other. And I also see congruent sides here, right, adjacent congruent sides. So we have two pairs of adjacent congruent sides and opposite sides that are not congruent. These two sides are not congruent, and these sides are not congruent. So we have opposite sides that are not congruent. But a kite is also a quadrilateral. Then we have different types of parallelograms. A rectangle. A rectangle is a quadrilateral, but it's also a parallelogram because both pairs of opposite sides are parallel. But it is a parallelogram with four right angles. Right? We see the right angle symbols here. We have a square. A square is also a parallelogram because both pairs of opposite sides are parallel. But a square is also a square is a quadrilateral because it's a four-sided polygon, and it's a parallelogram because it has both pairs of opposite sides are parallel and congruent. All right. Square also has four right angles, which makes it a rectangle. So square is a rectangle as well. Square is also a rhombus, right? Because a rhombus is a parallelogram with four congruent sides, right? So a rhombus is a parallelogram, it's quadrilateral, but it has four congruent sides. A square also has four congruent sides, right? But it also has four right angles. So a square is a rhombus because a square has four congruent sides. A square is a rectangle because it's a parallelogram with four right angles. A square is also a parallelogram because both pairs of opposite sides are parallel and congruent. And a square is quadrilateral because it's a polygon with four sides. So we're going to be asked to identify or classify the quadrilateral. Here I see a four-sided polygon. I see four right angles. I see four congruent sides. So I have to identify that as a square. That would be the most specific name. Here I have a quadrilateral, four-sided polygon. I have a pair of congruent adjacent sides here and a pair of congruent adjacent sides here. So I have two pairs of congruent adjacent sides. All right, and I have opposite sides that are not congruent. All right, opposite sides that are not congruent. So we would call that a kite. All right, so if we take a look at these examples here, and we're asked to classify them. Here I have a quadrilateral. It has, because it's a four-sided polygon, but it's a quadrilateral where both pairs of opposite sides are parallel, and more importantly, it has four congruent sides. So that's going to be a rhombus. All right, and it's a rhombus because it's a parallelogram with 4 congruent sides. Here we have one pair of parallel sides. These opposite sides are congruent, right? But it is a quadrilateral with exactly one pair of parallel sides, so that is a trapezoid. All right, and then our last example, here I have a quadrilateral where opposite sides are congruent. Opposite sides are congruent, so both pairs of opposite sides are congruent, but it also has 4 right angles, so that makes it a rectangle. All right, so we want to use the characteristics to identify, the different types of quadrilaterals. Okay. We also want to be able to find the missing angle of a quadrilateral, and we can use this rule here. The sum of the angle measures of a quadrilateral is 360 degrees. So if we look at this example here, we have W, X, Y, and Z. The sum of those 4 angles has to be 360 degrees. So we can use that characteristic of a quadrilateral to find the missing angle if I know 3 of the other angles. So we'd want to write and solve an equation here. Here I have X, and then I have plus 75, plus 70, plus the 115. That has to be equal to 360. So I write an equation that says that the sum of the angles has to be 360. We combine our like terms. So what is 115 plus 70 plus 75? All right, we add, that's 0, carry the 1, 7 and 7 is 14, 16, all right, carry the 1, so we get 260. So my next line is going to say x plus 260, all right, that's going to be equal to 360. To solve that equation for x, we're going to have to subtract 260 from both sides of that equation. Sloppy, that's 260. Right, that's going to be 0. So x is going to be equal to 100 degrees for the measure of the missing angle. Okay, let's try a couple of those. Let's find the missing angle here. All right, we see it's a trapezoid, and I see that trapezoid has 2 right angles. All right, we know one of the angles is 118, so I'm going to write an equation that says that. So we have x plus the 118 plus the 90 plus the 90 has to be equal to 360. All right, combine our like terms. So that's going to be x plus, what's 180? 90 and 90 is 180, 280, so that's, and 18 is going to be 298. So x plus 298 is going to be equal to 360. All right, we'd subtract 298 from both sides of that equation. It's going to be 0. So x is going to be equal to, what's that going to be? 62 degrees for x. X is going to be 62. Let's try this one here. All right, we'd have x plus 122 plus 122 plus 58 has to be equal to 360. 122 and 122, well, let's see. Right, that's what, 244. Let's do that. So 122, 122, 58, right? Because we got to find that sum. Right, that's 12, carry the 1. 2 and 4 and 1 is 5, and 5 is 10. 0, carry the 1. So it's 302. So our next line would be x plus 302 has to be equal to 360. We'd subtract 302 from both sides of the equation, and we wind up with x is going to be equal to 58 degrees, right, for the missing angle. Okay, let's try a couple more, right? Let's classify these quadrilaterals first. Here we have 4 congruent sides. Now listen, they certainly look like right angles, but I don't want to assume they are right angles, so I don't want to call it a square, right? So we'll call this a rhombus. All right, this next one, we have opposite sides parallel here, 4 right angles. All right, so that's going to be a rectangle. All right, and for these examples here, we want to be able to write and solve equations. All right, so let's do this one up here. We'd have x, oops, gonna have x plus 120 plus 80 has to be equal to 360. Right, that's going to be x plus 200 is is equal to 360. Oh, what did I forget? Forgot that 90 degrees, so let's redo that. Alright, forgot that 90-degree angle up there. I don't want to forget that. So let's do that again. We have x plus 80 plus 120 plus 90 has to be equal to 360. Alright, so it's 200, so we'd have x plus 290 has to be equal to 360, and we'd subtract 290 from both sides of that equation. That's 0. X is going to be equal to, what's that, 70 degrees for the measure of the missing angle. Alright, want to do the same thing with that example B. I'm going to do that down here, do it in black. Example B, we'd have 78 plus 102 plus 132 plus x has to be equal to 360. Let's see, what do we have there? 180, 280, 280, that's going to be 312. So we have 312 when we add up those three terms, plus x has to be equal to 360. Subtract 312. Subtract 312 from both sides of the equation. That's 0. X is going to be equal to, what's that? 48 degrees. Right? And then this last one, the measure of that angle here, looks like it's probably going to be 102, right? But let's check it. So we have 102 plus 78 plus 78 plus x has to be equal to 360. Let's see, combine our like terms. So we have 102, 78, 78, carry the 1, 7, 14, 15, carry the 1, so we have 258. So we have 258 plus x has to be equal to 360. Subtract the 258 from both sides of the equation. That's 0. X is going to be equal to, what's that? 62 degrees. Alright. Okay, let's try construction here. We want to draw a parallelogram that has a 60-degree angle and a 120-degree angle. Anytime we start with our constructions, we start with straight line. Alright. And then we need our protractor, so let's see if I can find that. Right, the protractor is going to be, let's see. I don't have the protractor in here. Let's type that in then. Right, protractor, let's see. And oops. Gotta delete that. Right, protractor. Alright, and let's say search that. And let's see, pictures. That's what we need. We need our protractor. Okay. So we take our protractor and we need a vertex. So let's use a different color so we see that. I'll put a vertex, I don't know, put it here. And we want to line up the protractor, the eye of the protractor right at that vertex. And we need a segment pointing through 0, so we do. And we want to measure an angle with 60 degrees and 120 degrees. So let's do our, if I do a 60 degree here, 0, 10, 20, 30, 40, 50, here's 60 degrees. Alright, right there. So slide my protractor out of the way. Let's connect that. 60 degrees. And then we need 120 degrees. Alright, but we need that to have same side of the line. Alright, so 120 degrees. Alright, 120 degrees, I need it going this way. So 0 and 120. 120 degrees would be right there at 60. Alright, so I'm using my outside numbers there. And then connect that. Now these lines need to be parallel. Let's measure the angles now. A 60-degree angle and a 120-degree angle. So let's measure this. 60 degrees looks good. Right, this angle here, right, I'm measuring, it's 120 degrees from here to here. Right, this angle here is obtuse and it's 120. This angle is acute. Right, it's going to be 60. And then we would just connect these 2 points here. Oops. Gotta straighten that out a little easier. Oops. Okay, and then make this a little shorter. That's alright. That's good. And shorter here. And make this a little shorter. And there we go. And there's our parallelogram with a 60-degree angle. And it's good to measure or label these. That's my 60-degree angle. And this would be my 120-degree angle. Alright. Okay. Alright, we have a couple more problems here. Give me some space. Find the measure of each one of these, and then I believe we'd be done. Alright, so we have, we have x. To find x, we add 100 plus the other 100 plus the 80 has to be equal to 360. That's going to have a sum of 280, so we have x plus 280. It's going to be equal to 360. That's supposed to be a 0. We subtract 280 from both sides of the equation. Subtract 280. That's going to be 0. So we wind up with x is going to be equal to, what's that going to be? X is going to be 80 degrees. Then the last example we have here, we start off our equation with x plus 81 plus 124 plus 90, right? Can't forget about the 90-degree angle. That's got to be equal to 360. Combine our like terms, so we have 90 plus 124 and 81. I want to add them together. That's 5. That's 10 and 9 is 19. Carry the 1. So that has a sum of 295. So x plus 295 is going to be equal to 360. And we subtract the 295 from both sides of the equation. It's going to be 0. X is going to be equal to 65 degrees. Alright. That's the end of the lesson today. I hope that's been helpful, and we'll see you soon.